Okay, so we have a person riding a Ferris wheel. Sam uses a stopwatch and notices that a person is at the highest point at 80 feet above the ground after 3 seconds, and after 7 seconds, the person is at the lowest point, which is 20 feet above the ground. All right, so my y-axis is my height, so we need to go to 80 and start at 20. So the first thing we need to do is figure out, okay, well, what is the number in between? What's that center line? To do that, we're going to take the max, which is 80, and we're going to add it to the minimum, which is 20, and we're going to divide that by 2. So 100 divided by 2 is 50. So again, this is my center line. So then I can label 50 in the middle, okay. So we also know originally at 80 feet above the ground, it was after 3 seconds, and when the person was 20 above the ground, it was after 7 seconds. So now we need to figure out, so we have 380 and 720. So let's figure out the number in between. So we have it's going to be at 50, but halfway between 3 and 7 is going to be 5. So at 5 is where we have our point right here. Okay, so if I connect these points, I'm going to have my cosine function. And we know that this is cosine because it starts up. So in this case, we're starting up at t equals 3. And then the last thing to note is that our interval from 3 to 7 here is only half the period because we only have half of a cosine function. Alright, so using this drawing, we are going to answer the question. It's below. Alright, so write a trig equation for the height h of a person above the ground as a function of time. So we need to figure out our amplitude and our period. So amplitude is your max minus your min divided by 2, which is 30. And our period is 2 times 4. And I got that because from 3 to 7 we have 4, and we multiply it by 2 because we only had half above. So this equals, so this is my period, so we have 8 equals 2 pi over b. So we have to solve for b because we're writing the equation, and our graph gave us the period. So when we solve for b, b equals pi over 4. I'm going to multiply both sides by b up here. And then when I divide by 8 on both sides, I get 2 pi over 8, which is pi over 4. So now we can fill in our equation. So we have y equals, our amplitude is 30 cosine, our b value is pi over 4, our shift was, we started at 3, so to the right 3, so that's t minus 3, and then our center line is 50. So using this equation, what will be the height above the ground of the person at 11.5 seconds? Well, 11.5 seconds is t, so that's where we're going to plug it in. Y equals 30 cosine pi over 4 times 11.5 minus 3 plus 50. When you get this, you get 77.7 feet. Now, make sure you're in radian mode to be able to get this answer. Alright, the last question, it says, find the first 2 times when t is greater than or equal to 0 when the height of the person above the ground is 70 feet. So now it says 70 feet, which is our y value. So we are going to do 70 equals 30 cosine pi over 4 t minus 3 plus 50. So what we're going to do is we're going to actually graph it, and we're not going to solve this. We're going to graph to solve for t. So you need to graph and set the window accordingly to make sure that you can see from 0 to, in this case, a 10 would probably just be safe. So to do that, in y1, I want you to put this function all in, and again, radian mode, and then put your extra parentheses right here when you plug it in. And then y2 is going to be 70. So then what you do is you do second trace, which is calculate, number 5, which is your intersection point. And you have to do that twice, so you get a time value of 1.93 seconds and 4.07 seconds. So we're going to be able to solve for this y value, we're going to use the graphing method.